Hello everyone. Today class number 28. Class number 28 for electrical machine 2. Okay. So today I will start the another two types of single phase induction motor. That is first one, right? The capacitor start, capacitor run, single phase induction motor. Third one, right? Third classification. Capacitor start, capacitor run, single phase induction motor. Right. For capacitor start, capacitor run, single phase induction motor, there are two capacitors. There are two capacitors. One of them is used to provide the starting torque. One of them is used to provide the starting torque, and another one is used to enhance the efficiency of the motor when it is in running condition. That is, one capacitor is present only at starting time. After reaching 75% of the rated speed, it will cut out, and the another one, that is that which one is permanent, that is at running condition the capacitor is present, is called the permanent capacitor. So this permanent capacitor is always connected in series, in parallel to the main winding. So so the circuit will look like suppose it is main winding, right? And VS supply is given. So this is your auxiliary winding, and this is C1 and this is C2, right? This is C1 and C2, and this is your centrifugal switch. Once it is off or on, okay? So this C1, right? This C1 is starting capacitor. Present up to 75% of rated speed, okay? And C2 will be the permanent capacitor. Present all time So right at the time of starting, CS, that is centrifugal switch, is closed, that is turned on. Centrifugal switch is turned on. So two conductors are active. So the two conductors are active then. So the starting condition, the motor has the same characteristic. So that at the starting condition, the motor has the same characteristics as of that of the capacitor split phase induction motor, okay? So after 75% of the rated speed, after 75% achieving of the rated speed, the centrifugal switch is opened, that is turned off, now it is turned off, right? Then only one capacitor, which is permanent, is present with the main winding, okay? So at the moment of starting, there are a flux phi C1 and phi C2 and phi M. There are three fluxes are present at the moment of starting. So this phi C1 and phi C2 will provide phi A. Okay, so phi C1 plus phi C2 equals to phi A. This phi A will produce the higher efficiency than that of the previous case, that is than that of the capacitor split phase induction motor. Okay, so this phi A will produce the more effective flux to the armature of the single phase induction motor. That is the phasor diagram will be, suppose this is, we are taking, this is phi m, the angle will be theta m. Okay, so this is your phi A. Okay, phi A is nothing but the addition of phi C1 and phi C2. Okay, whatever the suppose phi C1 and phi C2. Okay, this is phi C1 and this amount is phi C2. So phi C1 and phi C2 will be phi A, and this angle is theta A. Okay, so this theta A plus theta m, that will be equals to total angle, the angle between phi m to phi A equals to beta, and this beta is very much tends to 80 to 85 degree. Okay, so almost 90 degree, right? Almost 80 to 85 degree. So beta having a range from 85 degree to 80 degree. Okay, so it is more better compared to that of the capacitor split phase induction motor. Okay, so as it is tends to 90 degree, it tends to or very near to the 90 degree. Okay, so next its most important characteristics is its most important characteristics is it is a silent type motor. It is a silent type motor, that is less noisy, right? The noise is very small and very less, right? Noise generated is very less. That's why the use of this capacitor or use of this motor is taken in hospital, school, classroom, exam hall. Okay, so so this type of applications are is done for this type of motor. Okay, capacitor start capacitor run single phase induction motor is used in the in where there is a silence is required, right? Where silence is required, there the capacitor start capacitor run motor in this single phase induction motor is used. Okay, so the characteristics will looks like, the starting characteristics will similar to that of the capacitor split phase induction motor. that is suppose we are taking a torque. So when MW only, the characteristics will look like it is MW only. Okay, so when MW plus C1 plus C2, it will be enhanced. The starting torque is enhanced and the switching period is less. This is the switching period, and previously it was okay. So previously the steep, it is a larger than the compared to that of this case. Okay, and the starting torque is less, right? Previously it was only capacitor split phase, only the capacitor split phase it was looks like. Okay, so now it will be looking it will be follow this path. Starting torque will be higher compared to that of the, and the switching is less steeper. 0.75 ns or NR or ns. Okay, this is NR, and this axis is NR, right? This is the torque axis. Okay. So capacitor start capacitor run single phase induction motor having the application, right? Hospitals, studios, classroom, exam hall. Hospitals, studios, classroom, exam hall, church. Okay, so other places where silence is important, Okay, so this is all about the capacitor start capacitor or single phase induction motor. Okay, so now I will move into the last one, that is permanent capacitor single phase induction motor. Permanent capacitor type single phase induction motor. permanent capacitor type single phase induction motor, right? This motor is also called permanent split capacitor motor. Permanent split capacitor motor. The same capacitor is kept permanently in series with the auxiliary winding. The same capacitor is kept permanently in series with auxiliary winding both at starting and under running conditions. There is no centrifugal switch. Okay. So at a particular desired load, the capacitor and auxiliary winding can be so designed. The capacitor and the auxiliary winding can be so designed as to result in 90-degree time phase displacement between two winding currents. That is it. This concept is very much important. For this case, beta equals to 90 degree. That's why it is taken as a highest efficient type motor. That is permanent capacitor type motor is always beta equals to 90 degree. That is all time it will show the balanced situation by using two axes. Okay, the rotating magnetic field generated by two fields which are always remains balanced condition. Okay, so that means, right, so let us draw it first. There is no hard and fast rule that this terminal should connect it over here or this terminal should connect it over here. Okay, there is no hard and fast rule. You can connect by this way or vice versa. Okay, so whatever you can wish, you can easily connect it. Okay, so this is your rotor axis or this is the rotor axis or auxiliary winding axis. This is auxiliary winding or called rotor axis, and this is the stator axis or main winding axis. Okay, stator main winding axis. This is capacitor C. This capacitor C, right, C must have, right, capacitor C must have high thermal stability. That is capacitor either oil filled or paper capacitor. This capacitor is either oil filled capacitor or paper capacitor. That as because it must have some high thermal stability. Okay, so right, power rating for capacitor should be 100 watt. This power rating for the capacitor should be 100 watt. Capacitance equals to 2.5 microfarad. So capacitance, that is C equals to 2.5 microfarad. The capacitance value 2.5 microfarad / 100 watt. Okay, so power is also have to be written. Okay, so right, since auxiliary winding is always present, this type of motor is called two-phase motor. This type of motor is called permanently two-phase motor. Okay, permanently two-phase motor, and it is balanced, always remains balanced, as because the phase angle difference between auxiliary winding flux, that is phi of A, and the main winding flux, that is phi of M, is always be 90 degree. Okay, so the phase difference exactly 90 degree. Okay, the phase difference is exactly electrically 90 degree. That means whatever the flux is generated by this main winding, exactly 90 degree phase shifted it will generate by auxiliary winding. Okay, so this system will produce a balanced rotating magnetic field, right? A rotating magnetic field, which already I have been taught in the module number 2. Okay, rotating magnetic field can produce by two ways, that is balanced three-phase system or balanced two-phase system or alpha beta system. Okay, so alpha beta system means one condition is very much important, that two phases should be placed in the electrically separated by 90-degree phase difference. Okay, that's why the electrically phase difference by 90-degree. Okay, this is the 90-degree, right? This is the 90-degree, so that's why you're taken in 90-degree phase difference. Okay, so next, right? So IA as phi A and phi M produces the balanced rotating field inside the air gap, and one important concept is that for this case IA equals to IM. Whatever the current is flowing through air and another current is flowing through air, the magnitude remains same, right? The magnitude remains same. Okay, so next, right? For this case, the phasor diagram will be Vs, supply voltage Vs, right? And this is your phi M, angle is theta n, and this is your theta A, this is phi A. The angle between these two is 90-degree always, right? So that means beta equals to 90-degree. This is most important characteristics. Okay, so that's why Ia equals to Ia, magnitude of Ia equals to Im, and the phase difference of Ia equals to 90-degree plus angle of Im. Okay, so that means if we, and this, since capacitor is all time present, so that's why the okay, so it can achieve a higher starting torque as well as the running torque. Okay, higher running torque. Okay, so this is your NS inner rotor speed, and this is your torque axis. Okay, so this is the highest Tmax. Okay, so maximum torque will be higher than that of the all type of capacitor, all type of single phase induction motor. Okay, so the application of it, right? The applications now. The application of it will be, right, office, classroom, theaters, ceiling fan. Office, classroom, theaters, ceiling fans in which the value of the capacitance varies from 2 to 3 microfarad. So these capacitance vary from 2.5, that is we can take it as from 2 to 3 microfarad. Okay, so which is most efficient type induction motor, single phase induction motor, and can be used in very large scale. Okay, very large variety of applications. Okay, can be used in very large applications. Okay, so this type of classifications already done. So today's class up to this much. Next day I will start the condition for obtaining maximum starting torque for a resistance split phase induction motor and for the capacitance split phase induction motor. Okay, these two theorems you have to calculate, or conditions you have to find, then one numerical I think will be completed. So after that the chapter is completed. So waiting for next day. So thank you for today.